In this video, we're going to continue our work with solving quadratic equations using the square root property. In particular, we're going to be looking at equations that can be written as quantity squared equals a number. We're going to be looking at binomial squared equals a number. And you'll see that in our first example here. So let's take a look at this first one here. X minus 5 squared equals 25. And so you can see that we've got here a binomial squared on the left-hand side equaling a number. So binomial squared equals number. So anytime that you have something that looks like this, we can apply the square root property. You're going to want to get this binomial squared isolated, just like previously we isolated the quadratic term before we took the square root of both sides. So this particular problem is already set up for us to go ahead and use the square root property. So we've got here our binomial squared equals 25, square root of both sides, and we're going to remember that plus or minus on the right hand side. So we take the square root, then put a plus or minus here, and then they take the square root of 25. So this is our square root property, as you know. Okay, and then the square root of the quantity squared is x minus 7, because as you know, square root and squaring are opposite operations. They're inverses of each other, those operations, so they undo each other. And over here, we've got plus or minus the square root of 5. So now what we want to do is go ahead and split those up into two equations to solve for x. So the first equation would be x minus 7 equals 5, or the second equation, which would be x minus 7 equals negative 5. Solving for x, here we get a 12, and on this one we get a 2. And this one is pretty easy to check, isn't it? We can put the 12 into our original equation for x, subtract 7. And so here we have 5 squared, which is 25, so that definitely checks. Or, and then 2, the 2 minus 7 squared, this is negative 5 squared, which is also 25. So the solution to our quadratic, 12 and 2. Okay, let's go to the next one. So this is what I was talking to you just about. See, and number 6, we have a binomial squared equals number, right? So quantity squared equals number. So anytime that we have a quadratic like this, then the square root property is really good method. So we are going to isolate the squared binomial. Okay, so in number 6, that's already been done for us. Right? We've got the squared binomial by itself on the left, the number on the right. Okay, so we're ready now to go to the square root property. So, and again, we are going to remember that plus or minus. So square root of 5x plus 8 squared equals plus or minus square root of 9. So here, on that left-hand side, the square root of something squared, you know these are opposite operations, so you're going to end up with 5x plus 8. Okay, these are inverse operations, so they undo each other, right? And then over here, square root plus or minus square root of 9 means we have plus or minus 3. Okay, so now this is important. We still have to solve for x, because ultimately for these equations, when they tell us to solve, we're still solving for x. Right? So at this point, we are going to split up our linear equation, because we've got a linear equation here, right? This is linear. We're going to split that up into two different equations. The first equation is 5x plus 8 equals a positive 3. And then the second equation is 5x plus 8 equals a negative 3, right? So that could, those two equations came from the plus or minus here on the 3, right, from the square root property. Okay, and so now we're just going to solve for x the way you know how. So we'll subtract 8 Here we get 5x equals negative 5, divide by 5, so x equals negative 1. Over here again, we'll subtract 8. Here we get 5x equals negative 11, so x equals negative 11 over 5. So those are our two answers, right? And again, we can check them. We can check them using our calculator back into the original problem. All right, let's go to number 7. So again, look at this guy. We have that squared binomial, right? We've got that quantity squared. Problem being that it's not isolated. So our first step will be to isolate that. So we're going to go ahead and add the 14 to both sides. It looks like 360. And then we are going to divide by 2. Divide by 2 both sides, so we get x minus 5 squared equals 180. And now we're ready for the square root property, and we got to remember that plus or minus on the right-hand side. So x minus 5 equals plus or minus square root of 180. Okay, so here with this radicand, this square root of 180, we need to pull out any perfect square factors, right? We need to try to find those perfect square factors of 180. So definitely I see the 9 in there, don't you? 9 times 20. And then 20 we know is 4 times 5. So the 9 and the 4, these are perfect squares. So we're going to take square roots of all of these. This is based on past work we've already done, right, in chapter 8. But good to review. So this is 3. So 3 square root of 9 is 3. Square root of 4 is 2. And you multiply 3 times 2, which is 6 root 5. So we get here x minus 5 equals plus or minus 6 square root of 5. And now we are going to solve for x. We have to split this up into 2 equations. So I'm going to have to come up here because I ran out of room. So we have x minus 5, here's the first equation, equals positive 6 square root of 5. So we go ahead and add the 5 to the other side. Okay, and so now what I want you to notice is that I'm going to stop here, that I am not going to add this 5 and this 6 to become an 11 because these are not like terms, right? We did that previous work before. So this is your final answer. It's an irrational root. It's got that square root of 5 makes it irrational. Okay? All right, irrational root. Number 2, the second answer, because again, we expect 2 answers, don't we? With a quadratic is x minus 5 equals negative 6 square root of 5. And again, we're going to add the 5, so x equals 5 minus 6 square root of 5. And again, we're going to keep the answers like this. This is another rational root. And so our 2 answers are these interesting looking irrational numbers, right? By the way, we call these the exact answers. So sometimes in your homework, you may be asked to give a decimal approximation. And so you would then put these in your calculator and get a decimal. But these 2 are the exact answers to our quadratic. So I think we should check one of these, right? Good idea. Let's get that calculator out. Okay, so here we are at the calculator, and I'm going to use that Stokey again that I've used before. So I'm going to take one of these 2 answers to check. So I'm going to use 5 plus 6 square root of 5. And then I'm going to store that in x and hit enter. It gives me the decimal approximation, right? Okay, but now I'm going to go back to my original equation and type in that left-hand side. So 2 parentheses x minus 5 squared minus 14. Boom. And that's what I wanted to see. I wanted to see that if I substituted in one of my answers, I got the 446 on the right-hand side of the original equation. Perfect. Okay, let's go to the next problem. Okay, so now I want you to use the technique that you learned in the last problem to try this problem on your own. And I'm going to ask you to pause the video. And then once you start playing it again, I'll show you the answer so you can check yourself. Okay, so pause your video now. Okay, so how did you do? So the first step was to isolate the x minus 1 squared, right? So we went ahead and subtracted the 15, got a 375, and then here divided by 5, both sides, right, in the first step. So that gave us x minus 1 squared equals 75, which is our binomial or quantity squared equals number. So took the square root of both sides. Did you remember your plus or minus on the right-hand side? Good. Okay. And then you want to simplify square root of 75, which we know that's 25 times 3. So square root of 25 is 5. So we have x minus 1 equals plus or minus 5 square root of 3. Then we add the 1 to both sides. So we get x equals 1 plus or minus 5 square root of 3, and separate your answers. So you should have gotten 1 minus 5 square root of 3 and 1. Oh, there should be a plus here, shouldn't there? And 1 plus 5 square root of 3. So how did you do?